Happy winter break! This is part 1 of your winter break assignment. In this video, you will be learning about electron configurations. The goal of this video is to be able to write electron configurations. During this video, be sure to do all 4 of the things listed below. What is an electron configuration? An electron configuration is a combination of letters and numbers that tells us where electrons are located in an atom. They tell us 3 things: the energy level that the electrons are located on, the subshell that electrons are located in, and the number of electrons in each subshell. So electron configurations tell us where electrons are located and how many are located in each spot. During this video, we will only be talking about ground state electron configurations. Ground state electron configurations, well, when an atom is in its ground state, that means none of its electrons are excited. So all of its electrons are in the lowest energy level possible. There's been no energy added to the atom. You're familiar with Bohr diagrams. Each of these circles represents a shell. So a shell is represented by the letter N, and it is an energy level. So this is our first energy level, our second energy level, our third energy level, and so on. The first rule is called Aufbau principle. Electrons always fill the lowest energy level first. So they always start closest to the nucleus at our lowest energy level, and once that fills up, then they expand outward. So once each energy level fills, then they go to the next energy level. When we really look at the Bohr diagram, we see subshells. So subshells, or sublevels, are specific areas that electrons exist in. Different types of subshells are different shapes. So in our first energy level, n equals 1, there is only one subshell. We call that the S subshell. In our n equals 2 energy level, we have the S subshell, and we have a P subshell. In our n equals 3 sublevel, there is an S subshell, represented by this black circle, a P subshell, represented by this green circle, and a D subshell, represented by this orange circle. Notice that the 3D subshell actually has a higher energy than the 4S subshell. So according to the principle we just learned about, Aufbau's rule, the 4S subshell is going to fill before the 3D subshell fills, because electrons fill the lowest energy first. S can have 2 electrons. So once each black circle has 2 electrons, it goes to the next circle. So once this one has 2, then it goes to the next sublevel. So then it goes to the P sublevel, which can have 6 electrons. So once our P sublevel has 6, then it would expand, then the electrons would start filling the S sublevel, which could have 2. Once this one has 2, then it'll go to this P subshell, which can have 6. Then it'll go to this S subshell, which can have 2. And the D subshell can have 10 electrons. So this means that our n equals 1 can hold a total of 2 electrons, because it's just the S subshell. Our n equals 2 can hold a total of 8 electrons, because it's got this S subshell and a P subshell, so that's 2 plus 6. Our n equals 3 can hold a total of 18 electrons, because it's got an S subshell, a P subshell, so that's 2 plus 6, and a D subshell plus 10, 18 electrons. You can also, it might help to look at the Bohr diagram like this. So here, each sub-level, each energy level is color-coded. So our first energy level is red, our second energy level is green, our third energy level is blue, and our fourth energy level, our third energy level is orange, and our fourth energy level is blue. The fourth energy level expands past this n equals 5, because this is the S subshell of n equals 5, so the D orbital of n equals 4 would be out here, but the picture's cropped. So when we fill electrons on these Bohr diagrams and then convert electron convert the Bohr diagrams into electron configurations, we're going to start with hydrogen. Hydrogen has 1 electron, so it goes into the lowest energy level, the N equals 1 S subshell. These blue dots are going to represent electrons, so its electron configuration would be 1s1. This 1 represents our first energy level, the S represents the sublevel or subshell, and this 1 represents that we have 1 electron. So helium is 1s2. It's 2 electrons in the first energy level in the S subshell. Now we move to the second period of the periodic table. Lithium has 3 electrons, so they fill from the lowest energy. So once there are 2 in our 1s sublevel, then we have to move to our 2s sublevel. So the electron configuration is going to be 1s2, 2s1. Beryllium has 4 electrons, so now we have another electron in our 2s sublevel. So we have 1s2, 2s2. Boron has 5 electrons, so we have added an electron to our p, our 2p orbital, because our 2s is now full. Remember, s can only have 2 electrons. So boron is going to be 1s2, 2s2, 2p1. That's the electron configuration for boron. Carbon has 6 electrons. So again, we start from the lowest energy and we fill outward. Once each and we fill until we have a total of 6 electrons. So that's 1s2, 2s2, 2p2. Nitrogen has 7, so that's 1s2, 2s2, 2p3. Oxygen has 8, 1s2, 2s2, 2p4. When you add up these superscripts, it should equal the total number of electrons. That's a good way to check yourself. Fluorine has 9 electrons, so 1s1, 1s2. Now the 1s subshell is filled. So 2s2, 2s1, 2s2. Now the 2s subshell is filled. 2p1, 2p2, 2p3, 2p4, 2p5. We have a total of 9 electrons. So the electron configuration is 1s2, 2s2, 2p5. Neon has 10. So now we have 1s2, 2s2, 2p6. Now the second energy level is full, and we can move to the third period of the periodic table. Notice we're going to start by filling our 3s orbital. And remember, there can be 2 electrons in this sublevel. Then we're going to move to our 3p sublevel. And remember, there can be 6 electrons in a p sublevel. So what you need to do now is write out the electron configuration and draw the Bohr diagram for these following 6 elements.